Good morning, students. Today we are going to discuss the last four sums of exercise 7.1. So let's begin with question number 5. Line L is a bisector of angle A and B is any point on L. BP and BQ are perpendicular from B to the arms of AB. Show that first one, triangle ABP is congruent to triangle AQB, and second one, BP is equals to BQ or B is equidistant from the arm of angle A. So either we have to prove BP is equals to BQ or B is equidistant from the arms of angle A. Both the thing means same thing. Now this is a diagram that you can see. Now first what we are going to do when we are solving, we are going to write the given. So let us write the given. Write given L is the bisector of angle A. So that implies angle BAQ is equals to angle BAP. Also given is angle BQA is equals to angle BPA, that is 90 degree, that is also given in the diagram. Now next we will write to prove. The first to prove is triangle ABP is congruent to triangle AQB, and number 2 is BP is equals to BQ. So let us start with the first proving. First proof, triangle ABP and triangle AQB. You can see from the diagram that ABP and AQB are the two triangles. See, both of them have 90 degree. AB is common and angle BAQ, that is the top angle, is equals to angle BAP. So these two angles are equal. We have 90 and AB as the common side. So first when we are writing the proof, we will write angle BAP is equals to angle BQA, that is 90 degree given. Number 2, BAP is equals to BAQ, that is also given from our question, and AB is equals to AB, that is our common side. So the triangle ABPB is congruent to triangle AQB by angle side congruency rule. Since these two triangles are congruent, we can say that BP is equals to BQ by corresponding parts of congruent triangle, that is CPCT, corresponding parts of congruent triangle. So this is your question number 5. Now we will move on to the question number 6. Question is AC is equals to AE, AB is equals to AD, and angle BAD is equals to angle EAC. Show that AC is equals to DE. So AC is equals to DE. Now from the diagram only I am going to explain you. First we are going to write the given. So all these are our givens. That is AC is equals to AE, AC is equals to AE, AB is equals to AD, and angle BAD, that is this angle, is equals to angle EAC, that is this angle. Now when we consider the triangle ABC, this angle is missing. Angle 1 is missing. Also when we consider EAD, the angle 1 is missing. So when we have studied Euclid's geometry, there we have come across one axiom that when equals are added to both the side of an equation, the resultant is also equal. That means BAD is equals to EAC already provided. Now to that equation, if we add DAC, if we add this angle 1, we will get BAD plus DAC, total we will get BAC. So BAD plus DAC is equals to BAC. Again with EAC, if we add DAC, we will get EAD. So with EAC, if we add DAC, we are getting EAD. So with the equals, if we add one constant to both the side, the resultant will also be equal. So from here we got equation 2. Now to prove that BC is equals to DE, what we are going to do? We are going to consider the triangle ABC and triangle ADE. That is, we are going to consider the triangle ABC and ADE, this triangle. Now on considering those triangle, we got AB is equals to AD, that is provided in the question. BAC is equals to angle EAD, that we have found out from equation 2. And AC is equals to AE, that is also provided in the question. So the triangle ABC is congruent to triangle ADE by angle side congruency rule. Since these two triangles are congruent, we can say BC is equals to DE by CP/CT, that is corresponding parts of congruent triangle. So here we have only added this angle 1 to the equal angles, and we got the third requirement to prove congruency. The two already given, the two requirements, the first two is already provided. The third requirement was an angle. So adding this equal angles, we got the triangles as congruent, and then we said that BC is equals to DE. Now question number 7 is similar to question number 6. The diagram is different, but the sum is similar to question number 6. Here also, see, if I explain you from the diagram, it is said that AB is a line segment and P is the midpoint. So AB is a line segment, P is the midpoint. D and E are a point on the same side of AB such that BAD, that is BAD and ABE, these two angles are equal, given in the question. And EPA and DPB, these two angles, the double marked angles, are also equal. So we got two angles on one side. P is the midpoint, so AP is equals to PB is a point that is already provided in the question. Angle A and angle B is equal, that is also provided in the question. And this angle P is written like EAP is equals to DPB. To these angles, if we add the common angle 1, then we can say angle DAP is equals to EPB. Now which triangles to consider? For considering, first we need to see what we need to prove, that is show that DAP, locate triangle DAP, that is this triangle, and EPB, that is this triangle. EPB and DPA, these two triangles we need to show congruent. To show that congruent, we have already we have with us sides are equal, angle is equal. So one angle is left, this part. If we consider DAP, we need DAP angle, and if we consider the triangle EPB, we need EPB angle. And to find that angle, this angle 1 needs to be added. Okay, so first what we are going to write? We are going to write given. P is the midpoint, so AP is equals to PB. Angle BAD is equals to ABE, that is BAD is equals to ABE. So BAD can be written as PAD and ABE can be written as PBE. So I have changed it little bit so that we can correspond it to the triangles. Since the angle remains unchanged, we can write like this. Now another equation that we have is EPA is equals to DPB, that I have already said. EPA is equals to DPB. Now to this equation 1, we are going to add this common angle 1. Common angle is EPD. This common angle 1 is to be added. If we add this common angle 1, we will get DPA, that is DPA, and EPB. So we are getting this common angle. So when we are considering this shaded triangle and the unshaded triangle, we added this angle 1 to the equation 1, and we got the angle DPA and EPB, which are equal to each other, which forms our equation 2. Now to prove was triangle EPB to prove was triangle EPB is equals to triangle DAP. So DAP and EPB, we are considering these two triangles. So the first one is PAD is equals to PBE, PAD is equals to PBE. Second is AP is equals to AB, PB. And the third one is DPA is equals to EPB. So the three requirements for congruency is proved. Therefore, triangle DAP is congruent to triangle EPB by angle side angle congruency rule. Number 2 was AD is equals to BE. Since the triangles are congruent to each other by angle side angle, we can say AD is equals to BE by corresponding parts of congruent triangle. So this sum is similar to question number 7 is similar to question number 6. Now the last sum, and it is a little bit bigger, that is question number 8. So in the diagram you can see that it is said in a right angle triangle ABC, right angle that C, so this angle is 90 degree. M is a midpoint of the hypotenuse AB, so BM is equals to AM, we have already got that. C is joined to M and produced to D such that DM is equals to CM, and D is a point joined to B. Show that these four are our required to proved. So first we will write our givens, that this angle is 90, BM is equals to AM, DM is equals to CM. Then to prove, the fourth proof that we need to show, and then we will start our first proofing. Now first proofing, we have to show that triangle AMC is equals to triangle BMD. So triangle AMC is equals to triangle BMD. Now this dotted triangle are to be shown that they are equal. We already have AM and BM are equal, DM and CM are equal, and angle M is vertically opposite since the line intersect at M. So we will write, considering triangle AMC and BMD, AM is equals to BM given, angle AMC is equals to BMD vertically opposite, and CM is equals to DM, that is also given. So the triangles are congruent to each other by side angle side congruency rule. So with this congruency we can say AC is equals to BD. By CPCT, so we can say AC is equals to BD by CPCT. So our first proof is done. Now the second proof is angle DBC is a right angle triangle. We need to show this angle is right angle triangle. Angle C is already 90 degree. we need to show angle B is also 90 degree. So first we will write triangle AMC and BMD are congruent by side angle side congruency rule. Since they are congruent, angle MDB and MCA are congruent to each other, that is equal to each other. This angle and angle D, angle MCA and MDB are equal by CPCT, and also they are alternate angles. If we consider AC and BD a line and CD as a transversal, then we can say that these two angles are alternate angle. So that is what we have written. These angles are alternate angles. Since these angles are alternate, we can imply DB is parallel to AC. Since these two angles are alternate, we can say AC and DB are parallel lines. Now we have studied that a property of a parallel line, that is sum of co-interior angle is 90 degree, that is this angle and angle B is 180 degree. Sum of the co-interior angle is 180 degree. So I have written DBC plus ACB is equals to 180 degree. That implies angle DBC plus 90 is equals to 180. Transpose this side, so 180 minus 90, we get 90. So angle DBC is a right angle triangle. So it is also proved. This angle is actually 90 degree. Now the third proof was to prove triangle ABC. Now we change the triangle to the shaded triangle and the dotted triangle. The right hand side triangle as well as the left hand side triangle. In triangle DBC and ACB, what we have seen? We have seen BD is equals to AC, that is from our first equation CPCT that we have got. BD is equals to AC. Angles are at 90 degree. Angle B and angle C is 90, and BC is a common side to both the triangles. So BC is equals to BC. So these two triangles are congruent by side angle side congruency rule. So our third required to prove is also proved. Now our fourth was CM is equals to half of AB. This equation we have to prove. So come to question solving of number 4. Since triangle DBC is congruent to triangle ACB by side angle side, that is this proved, we can say CD is equals to AB by CPCT. When two triangles are congruent, their arms, that is the sides and angles, are also equal. So we can write CD is equals to AB. To this equation we divided by half, or divided it by 2. So we can write half of CD is equals to half of AB. Now half of CD is CM. Since in our question it is given DM is equals to CM, that means half of CD is CM or DM. Since in our required to prove it was CM, so we will use CM. We have written the reason as since M is the midpoint of CD. So CM is equals to half of AB. So it is also proved. So today we have discussed 4 sums of exercise 7.1. Please go through this again. If you have any confusion, just send a comment and I'll try to reach to you. Thank you so much for the tutorial listening.